Hey little mathematicians, this is our last video. I hope you're excited to learn about inscribed angles. So real quick, before we pop into the examples, let's get a definition on what an inscribed angle is. So let me show you a picture first. So here's our circle, and an inscribed angle is going to look like this. So hopefully you understand that this is different than a central angle because its vertex is not in the center. So an inscribed angle is an angle in a circle in which all 3 points touch the edge of the circle. So an angle in a circle with all 3 points on the edge of the circle. Okay, and the degrees are also different. So this is going to be a little crazy. So watch this. So these are not the same. So if we look at this arc right here, okay, this arc and the angle are not the same degrees like the central angles. So this angle, let's just say it's 30 degrees. Now what I usually do to help myself remember this is that I think of this as an ice cream cone. And that usually when you get an ice cream cone, you want more ice cream than you do cone, because ice cream is the good stuff, right? So therefore, this part of the angle, so the arc, is actually more than the cone. In fact, it's 2 times more. So in order to get the value of the arc, you have to multiply by 2. So this time, the arc's measurement is 60, but the inscribed angle is 30. So that's the rule, if you want to write that down. An arc is equal to 2 times the angle, and this is only for inscribes. Or you can think of it as the angle equals half of the arc. So just to show you another quick example, just so you get the main idea here, let's say I have this circle here, and let's throw in an angle right here that we know, a central angle. So let's say that this is 80. So if we know that this inside angle is 80, the arc on the outside is also going to be 80. So let's draw an inscribed angle from this. So now let's finish this and let's make a cone out of the inscribed angle. So you can see here that this angle of 80 is clearly bigger than this inscribed angle. So the central angle being 80, the inscribed angle is less than that. So in order to get there, you would divide by 2, and that would give me 40. So inscribed angle is always half of the arc, but central angles are equal to the arc. So now we're just going to practice a couple examples to help you more. So I'm going to give you a second to copy this example down, and we're going to try this.
Yeah, buddy, rolling like a big shot, Chevy tuned up like a NASCAR pit stop. Fresh paint job, fresh inside. Is the outside frame in the trunk wide? Or the rims big? Do it right good. Lean back, right hand on the sidewheel.
Alright, so hopefully you had a second to write this down, and let's take a look. We only have 2 questions to answer with this picture. So the first question they asked for is ADC. My suggestion is that you highlight things. Get some highlighters, get some colored pens, because these pictures are going to get cray. So let's start with ADC. I'm going to highlight this in yellow. ADB is what I'm looking for, not ADC. My bad. So ADB is what we're looking for, and I'm also going to go ahead and fill in the arc here. So if you get in the habit of doing this with a certain color, it's going to be helpful to you. So hopefully you remember the rule that you want more arc, you want more ice cream than you want cone. So in order to get this angle, we're going to look at the 76 that we already know, and to get the inside, or to go to the cone, you have to divide by 2, because again, we don't want as much cone, we want more ice cream. So 76 divided by 2 is going to give me 38. So this value on the inside is going to be 38 degrees. The next question they want then is DC. So DC is right here, and what would be helpful is to also highlight the cone that goes with that arc. or the angle that goes with the arc. So in this case, if I want to know DC, which is out here, I'm going to have to look at 45. And remember, you want more ice cream, so in order to get outside the circle, you're going to multiply by 2. So 45 times 2 is going to give you 90, so this arc is going to be 90. And again, if this helps, just to show you why, if I were to draw a central angle right here, okay, this angle is clearly 90, and it's bigger than this inscribed angle, and they share the same arc. So in order to get that smaller angle, you would divide by 2. Alright, now there's 2 other rules that will help us follow some of these things. So the first rule states that if inscribed angles share an arc, then they are equal. Now that makes sense, but let's take a look at what that means. So we'll draw a circle, and we're going to draw 2 inscribed angles that have the same arc. So I'm going to start with drawing an arc first. So let's say that this arc is, let's go 100 degrees. And so I'm going to draw 2 angles that come from this arc. So here's an angle, and we'll name this angle arc. Real creative, I know. And then let's draw another one, again, that has the same arc, so AC, and we'll draw it over here. And we'll call this one ATC. So ARC and ATC are going to have the same measurement because they both have the same arc. And remember, in order to get from the outside to the inside, you want less cones, so you're going to divide by 2. So both of these are going to have the same measurement as 80 and 80. So this is just something you might see. So if you see this butterfly looking shape, you would know that they would measure the same value because they have the same arc that they share. Okay, one more rule is an angle that's inscribed in a semicircle equals 90 degrees. Now this hopefully makes sense, but let's again take a look at what this actually looks like. And the key is like trying to find this in examples because it's sometimes tough. So here's an example of a circle. Well, it's kind of a, lopsided looking circle, but you know what I mean. Here's a circle. I cut it in half to show that I have a semicircle. So if I have an angle that's inside of this semicircle, like meaning that its ends are right here. So let's say I'm going to go like this, like so. So if I have this angle, that means that this here is my arc. So that should make sense. How much is this arc right here? 180, right? Because it's a semicircle. So in order to get the degree of the inscribed angle, I would divide by 2, and that would give me 90. So hopefully this one makes sense, that it's a rule that if you're inside a semicircle equal 90, because that is half of a semicircle. Alright, now we're going to do a more complicated picture. Whoa, 0 to 100, real quick, I know. This is going to be the hardest thing I could give you. It's got a lot of lines going on, a lot of crazy things. So let me give you a second to copy it down, and then we will go over how you should think through a problem like this. Alright, now my suggestion would be again to get some colors, get some highlighters, and really try to focus on what's the arc and what's the angle that goes with the arc. So the first one they're asking for is arc PN. So I'm going to highlight this from P to N. And then you only have 2 values. You either have 92 that you can work with or 68. So 68 is going to be the one we want because that's the one that completes my arc. Just like that. So we're going to use the 68 to help us figure out what PN is. So remember, you want more ice cream, so you're going to want to double the 68 in order to get PN. So if you multiply 68 times 2, you're going to get 136. So PN is going to be 136. Alright, the next question then is asking you for LNP. So again, I'm going to highlight this. I'll do this in orange, LNP. It's this angle. And so hopefully you're already saying to yourself, 92, 92, woo, woo, woo. So this is the one I want to use, 92. And so this value gives me the arc. Remember, you want more arc, so you need to cut 92 in half to give you the value of the angle. So 92 divided by 2 is going to give you 46. So you're going to have 46 right here in this angle. And what I would do is definitely fill this in because you may need to use these values to help you find other angles. Alright, next one is going to be PMN. So I'm going to highlight this in green. Now this one is really tricky because this one, if you look real close, it's also forms that butterfly shape with this angle. So this goes back to rule number 1 that says when you have the same angle and the same arc, they should be the same. So if you notice here, both of those in the green and the purple have the same arc. So that means 136, cut it in half. This would be 68, just like this angle over here, because you have that butterfly looking shape. Okay, next one. Whew, this is getting messy. Alright, let's go to P and M. Alright, so I'm going to highlight this in yellow. So do you notice anything exciting about this? Perhaps it would be helpful to highlight the arc. So I'm going to highlight the arc here. And, sorry, I erased that to make it a little less confusing. So P and M. So I'm going to highlight this arc here. And if you notice, this arc is in the semicircle. So that means this is one that is inscribed in the semicircle, so you have a 90-degree angle right there. So PNM is going to be 90 degrees. Now, last but not least is angle MN. So angle MN out here, what you're going to do with that one, now we already know that this one is 136 out here. So what you can do is you can just notice that this whole thing from P, N, and M, so this whole guy right here is equal to 180, so you can do 180 minus 136, that gives you 44, and so the rest of this is 44. Now clearly there's other things you can do in here, but I'm just going to hit pause and have you come to class ready to try some of these grown folk problems.